This is Physical Science 1, Chapter 5, Part 1 on energy. In this portion of the video lecture, we will be discussing the nature of different types of energy. In our last unit, we've been talking a lot about motion and how motion occurs with forces and pushing and pulling. Now, motion is going to indicate that there is some sort of energy involved as well. So every change that occurs that you see around you, either large or small, is going to involve some sort of energy. These changes may not be directly visible, but they are occurring. So energy is the ability to do work and to cause change. So when something is able to change its environment or itself, then that object has energy. And energy will transfer from object to object. So we have different forms of energy. We will get into all of these in this chapter through various labs and activities. Kinetic energy is the energy of motion. We just covered that in our last unit. Remember, motion occurs when your change in point of frame of reference is different. Potential energy. These are stored forms of energy. So potential energy, we can have elastic energy, chemical potential energy, or gravitational potential energy. Now, kinetic energy is the energy of motion. So the energy of a moving object depends on the object's mass and its velocity. So we can calculate the amount of kinetic energy in an object, knowing how much mass it has and how fast it's traveling. The unit used for kinetic energy equations is the joule with the capital J. The joule was named after Prescott Joule, who developed the ability to calculate that kinetic energy, that energy of motion in an object. So potential energy, again, even motionless objects can still have energy. It's not directly seen, but it is there. So potential energy is stored energy due to position. And we will talk about the different types of potential energy of elastic potential, chemical potential, and gravitational potential energy. Elastic potential energy is energy stored by something that can either stretch, as in like a rubber band or a bow and arrow, or it can compress like a spring. So in potential energy, the stored energy of that position is converted to kinetic energy, or the energy of motion. So when the spring is compressed, it has elastic potential energy. When that spring lets go, that elastic potential energy converts to kinetic energy. Same thing with the bow and arrow and the rubber band. Once that stored energy is released, then kinetic energy will occur. Chemical potential energy. This is the type of energy that's stored in chemical bonds. When chemical bonds are formed, energy is absorbed, and when chemical bonds are broken through chemical reactions, then that energy is released. So we can take a look at inorganic chemical potential energy with unleaded gasoline. So the compound or the bonds in the gasoline molecule, when those are broken apart by combustion, it makes your car move and go forward or backwards, depending, I guess, on what gear you're in. But that chemical potential energy is changed to kinetic energy. In the case of organic types of chemical potential energy, things like foods, the breakfast and lunch that you've had so far today, or perhaps maybe even the dinner that you've had this evening, those bonds that make those foods, once they are broken, you get the unleashed chemical potential energy from the food, and you will get that mostly in the form of what we call mechanical energy. So your body is able to do all of its different metabolizing activities. Gravitational potential energy is energy that is going to be stored by objects due to their position above the Earth's surface or due to their height above the surface. We can calculate the amount of gravitational potential energy in an object, knowing how much mass it has and knowing how far it is above the ground. We also include our acceleration of gravity constant in there as well. Now remember, acceleration due to gravity on Earth is 9.8 meters per second squared. So you can take the mass of an object, multiply it by 9.8 meters per second squared, multiply that by the height it is above the surface, and you will have its gravitational potential energy also in joules. So the gravitational potential energy, or the GPE of an object, can be increased by increasing its height above the ground. So the further something is above the ground, the more gravitational potential energy it contains. If two objects for some reason were at the same height, the object that would have a larger mass would have more gravitational potential energy. So with the images on the bottom of the screen there, the little man on the stairs, he has the most potential energy at the very top step because that's as far above the ground as he can get. His potential energy would become less as he traveled down the stairs. And with the example of the objects with two different masses, again, the one with the larger mass will have more gravitational potential energy. This has been Physical Science 1, Chapter 5, Part 1 on energy.